All right, here we are at question 2, part D of the 2022 AP Calculus AB Free Response Calculator Required section. Well, if that isn't a mouthful, I don't know what is. So I've covered A, B, and C, the previous parts, in 3 other individual videos, and we're covering part D only in this video right here. So let's take a look at part D and where we're at with that. So it starts off and tells us we've got a vertical line in the XY plane that travels left to right along the base of the solid described in part C. So if you go back to the part C video, what we know is we have the base of this square that is in between these two curves here. And if you go back to the previous videos, we know that f of x, our natural log graph, is the top graph, and g of x, the x to the fourth plus 2x cubed, is our bottom graph. If you don't, the easiest way to do that is just to graph both of those. It's a calculator required section to see which is which. And so what we've got right now is this thing here is going this direction. That blue line right there is traveling through that space left to right. And they're telling us that the vertical line is moving at a constant rate of 7 units per second. So here we are talking about a rate of change, and a rate of change with respect to time. And we're talking about how it's moving in the x direction, because it's moving left to right here. So what they're telling us is that dx dt, that rate of change is 7. They now want us to find the rate of change of the area of the cross section with respect to time. So what they're asking us to find right now is they want us to find dA dt. So how is this thing changing when the vertical line is at a specific position when x is equal to negative 0.5? So when you start seeing these DT pieces coming through here, this really is bells and whistles are going off that we're looking at sort of a related rates problem. We're talking about a derivative that we haven't talked about in any of the other problems, and we're talking about it with respect to time. And that language with respect to time is why I'm calling these DTs on the bottom here, right? So what we're doing is we're taking a new derivative now. We're starting with the area formula. So they told us that a of x, that was our area formula. We talked about that back in part C. We created that by finding the area. Our area formula was the area of a square. And what we now need to do to this thing is we need to take the derivative of it, because we want to find the derivative of that area with respect to time, the rate of change with respect to time. So what we're looking at, again, this is implicit differentiation. It's related rates. It's kind of the category it sits under, but that's just math talk for saying it's a word problem that needs you to use implicit differentiation. So as you go to take the derivative of something like this, derivatives, you still have to remind yourself that you've got chain rule, product rule, quotient rule. All these rules still apply. And so because we have this x inside here, which isn't our standard variable that we're taking the derivative of, this is actually going to be a chain rule derivative. And so my little saying for the chain rule, you got to have little recipes for all your derivative rules. My saying is d in times d out. So as you come through here, you're taking the derivative of each of these pieces. And so this a with an x inside, that's a composite function. So we need to start by taking the derivative of the inside. So how I would say this is I would say that this is equal to the derivative of x on its own would just be 1. But we're doing implicit differentiation. And my little mantra that I use when I'm doing implicit differentiation is every time I take a derivative, I get extra stuff. And what that extra stuff looks like is sort of envision there being this little box behind that D right there. And so what you're going to do is you're going to be filling that box in with the letter of whatever you just took the derivative of over, in this case, dt. So we take the derivative of x, that was 1, took the derivative of an x, so I get a dx dt. That's my derivative of the in. The weirdness when you're doing the chain rule with implicit differentiation is the only piece that gets the extra stuff is the d in, because you're multiplying these two things together. If you think about it, your product rule and your quotient rule, you're adding and subtracting pieces, so everybody needs the extra stuff. But here, because we're just doing the chain rule version of implicit differentiation, the only person that gets the extra stuff is the d in. So now coming through and taking the derivative of the outside here, the d out, well, that's just going to be a notation game. That's a prime, and then when you're taking a chain rule, you leave alone the piece on the inside that you already took the derivative of. So this is our derivative right here. And they would actually give you a point. There's 1 point of our last 2 points that we can earn on this. That would be 1 point from just taking that derivative. Now to find our final answer, we need to plug values into that derivative. Well, we've got a value for dx dt. They gave us that value back in the language of the problem. And then what we need to do is plug in negative 0.5 for x in that situation. So if we replace those pieces, we're looking at 7 for the dx dt, and then we want a prime of negative 0.5. A prime of negative 0.5, we can actually find that in our calculator. We can do that in our calculator in about 2 seconds. And how we would do that is we would go ahead and in y1 in the calculator, we would put that area equation, which you should, luckily, if you didn't clear everything out, still have in there from part C. So our area formula from part C was a big parentheses around the natural log of x plus 3 minus, and then parentheses around this second piece because you're subtracting that whole chunk, and all of that was squared. That's in our y1 right now. Then we're going to graph that, and we're going to do a second calc, and inside the calc menu we're going to choose the number 6 option, which is dy dx, because what we're looking for is the derivative of this area formula with the specific x value negative 0.5 plugged in. We'll hit enter after we type in negative 0.5, and at the bottom of the screen that's going to say to us dy dx equals, and that will be our a prime of negative 0.5 value. And then we'll pop that and multiply it by 7. So open up our calculator. You know, if you're following through from the other videos, you've already got that area formula in the y1. And so from there, you'd hit the graph button. And now we'll go through this calc process. We'll hit second, calc. We'll choose the number 6 option in that menu, which is dy dx. Hit enter on that. And then we're going to type in that x value they gave us, which was negative 0.5. We hit enter, and at the bottom of the screen, it's giving us out our value of negative 1.324551. So that is our dy dx, negative 1. What was that? 3324551. So that is our, another way of saying, that is our a prime of negative 0.5 value right there. And so to finish this problem out, we're just going to take and plug that in right here. So we're going to do this times the negative 1.324551, and then shoving that into the calculator. The nice thing is in this situation, you've actually got that value stored in your calculator right now. So you could just do answer times 7. Whenever you've got a number, whenever you calculate something in the graphing area, it always stores that as your answer. So we could get out that, or we could just come back in and type negative 1.324551 times 7. And we get out negative 9.271857. Generally, for a final answer on these tests, AP Calc tests, they just want it to 3 decimals. Keep it to 6 when you're doing your calculations, and then round it to 3 on your final answer. So we'd be looking at negative 9.272. And then you want some units here. Well, they don't give us like meters or anything like that, right? They're talking about units per second. And so this is a change in area. Remember that we were just figuring out dAdt. So this is going to be units squared, whatever the heck the units are. And then our time units on this were seconds. So when you're going to figure out your units, just kind of go back to this differential notation. It's area units over time units. And so this would end up being our final answer on this problem. And that would be where our second point comes through. So that would be point number 2 for our second point, and completing all 9 points on this whole entire question too. So just a little implicit differentiation. Once you saw that, it was pretty straightforward. Most of the calculations were in the calculator. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.